let's talk about Module 5. So this is kind of an introduction with some information that we usually go over in class. Specifically, if you go to D2L and go Module 5, Gaming Part 1, usually in class we start off with this rolling dice class activity. I put it up here because I think it's fun and you can follow along if you want to. But when you open that up, it looks like this. We start off with something pretty familiar. Many games involve rolling dice, and the most common example is you roll 2 dice with 6 sides each, and then you add them together. And so you can see what the distribution of outcomes looks like. So I went ahead and completed this. You can do it yourself if you want to follow along or just listen. So the idea is we have 2 dice, each have 6 sides. So we have the first die has sides 1 through 6. Our second die has sides 1 through 6. So how many total possibilities for die rolls is that? Well, 6 for the first one and 6 for the second one means 6 times 6, so there's 36 total possibilities. And you can see that I filled in that here, this through this block. The highlighting is the same color, which is unfortunate, but there are 36 total possibilities. And here I just filled in each block here with the sum. Like if I get a 1 and a 1, I get 2. If I get a 2 and a 1, I get a 3. If I get a 5 and a 3, I get an 8. If I get 6 on each one, I get a 12. So just you look at here, when you roll 2 dice, you can see that there's only one way to get a 2. You have to get a 1 and a 1. But to roll a 9, you could get a 6 and a 3, or a 5 and a 4, or a 4 and a 5, or a 3 and a 6. And order matters here because the 2 dice are 2 separate objects. So 3 and 6 is different than 6 and 3. But if you get 6 and 6, there's no other way to write that. It's, the same either way. So now we summarize this table. And one important assumption we're making here is that these are fair dice. That means that each number is equally likely. You're just as likely to get a 1 as a 5, as a 3, as a 2, as a 4, as 6. Same thing with the second die. So each of these 36 options we have here have the exact same probability. So if we summarize this, here are different possible sums, 2, 3, 4, 5, 6, all the way up to 12. How likely are each one of them? Well, there's only one way to get a 2 out of 36 total possibilities. So it's 1 in 36 chance. And if you round that to 1 decimal place, you get 2.8%. Similarly, to get a 3, there's 2 possibilities, 2 and 1 or 1 and 2. So 2 out of 36. And you can keep going. You notice that the most likely outcome is a 7, which occurs 6 times here, 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 and here. That's just because there are the most ways to get a 7 on 2 dice. 6 and 1, 5 and 2, 3 and 4, 4 and 3, 2 and 5. Okay, I forgot what order I was writing those in, but that's why we'd usually write them down. But either way, there's 6 ways to get a 7. So normally in class, we would actually generate some random numbers. For example, if you wanted to fake rolling a die, you could just use this command, equals ram between 1, 6. And if you do that twice and add them together, you would get the sum of 2 dice. Or random.org/dice is a site that allows you to roll it as well. So if you wanted to, you could do that 36 times or 100 or 1,000 or whatever and see how your probabilities here compare with these. But let's just move on. So one other thing you can do, normally we'd write this by hand, but here I used Excel to make just a simple bar chart of the probabilities. Now we can see this interesting pattern appears where 2 and 12 are the least likely, 7 is in the middle, and you get this triangular shape in the middle. And that's what happens when you do a sum of 2 dice. It'd be different if you did a sum of 3 dice, 4 dice, 5 dice, but it's much tougher to do that, here, because we need 2 dimensions for 2 dice, so we don't usually have more dimensions than that on paper. But one last thing is that not every game of chance is going to use the sum of 2 dice. Suppose there's another one where we're still rolling 2 dice, but instead of adding them together, we're going to take the maximum of the 2. So we're not adding them, just whichever one is higher, that's what we get. This comes up in some games, though it's not as common. So we fill this in. If we get a 1 and a 1, the maximum of that is 1. If we get a 5 and a 3, though, the maximum is 5. So you fill this in. If you get a 6 and a 1, the max is 6. So anytime either die comes up a 6, you get 6 as your maximum. So you summarize these. Now the outcomes are 1, 2, 3, 4, 5, and 6. You're not adding them together anymore. It's just whichever one's bigger. So you calculate the probability of each of those. 1 comes up 1 in 36 times. I have a typo here. 1, 3, 5, 7, 9, 11. And you can make a little plot of that as well. And for the max of 2d6, you still get this nice straight line here. It's sort of a triangle, just a different shape than the other one. So the file that you see on D2L, it's organized a little differently because we usually do this by hand, so you can print it if you want to. But it goes through the same thing, then it adds a couple more. If you want to test yourself, you could also do a minimum of 2d6. So make the same table, but instead of taking whichever one's higher, take whichever one is lower. And another fun thing to do, I don't think this comes up in any games, but you can do it mathematically, is just take the difference of the two. So instead of adding them together, do die 1 minus die 2, and you'll get some negatives, but that's okay in math, and you get some very familiar patterns for both of these. That's about it for rolling dice. We'll circle back to this in a little bit, but for now, bye.